Again, just tell me now.
Sir, I have a doubt on slide 6.
Slide 6. Slide 6. Okay,
Yes, sir.
okay, okay. Sorry. Slide 6. Yes, tell me.
So in this, the equation where we have the term e to the power mu alpha,
Mhm.
you told that we have to take the lower value. So I could not understand why, if you can tell.
Okay, okay. Now, for the remember that for belt drive, use the equation A. Select either this for the driving pulley. Okay. Uh, you understand this subscript? I suppose means
Yes, sir.
mu into alpha combination for driving pulley or mu into alpha for driven pulley. Okay, whichever is lower. Look. Suppose I just take an example. Clear? Now here in the earlier picture. So can I go back to the earlier picture? I mean just one slide
Yes.
behind. Okay. So here I come down for an example. So in this particular case where the angle of wrap is lower, obviously for the driving pulley, isn't it?
Yes, sir.
Hello? Angle of wrap is lower for the driving pulley and angle of wrap is higher. Obviously, it will be higher for the driven pulley. Now, let us assume that mu is constant. Anyway, I am considering mu could be different. Alpha also is different. That is obviously obvious for this particular one. Mu also can be different for both the pulleys. Okay, one is made of wooden pulley, another is say steel pulley. Okay, so that could also happen. Anyway, just for an example, I mean, I was considering mu to be same to make it simpler. Now, what is happening that in the equation T2 by T1 equals to e to the power mu theta, the ratio of T2 you are determining. Now, if e to the power mu theta, suppose one value is coming lower value. So which one will be the lower value in this particular case? For the driving pulley, it will be lower value.
Yes, sir.
Yes, sir.
Driving pulley, it will be so e to the power mu theta will be driving pulley will be lower. Okay,
Yes.
so oh, some noise is coming from some. Okay, so obviously say that particular value is coming out to be after this coming out to be 2. All right, that
Yes,
is
sir.
coming out to be 2, and for this one for the driven pulley it is coming out to be 3. Okay, so
Yes.
what is the ratio value? So T2 is 3 times T1 in the for the driven pulley, and this is 2 times T1 for the driving pulley. So obviously, what will happen if I try to compute whatever may be the value of T1? Okay, so T1 and T2 are same for the belt. A same
Yes.
belt cannot have different tensions. Okay, so
Yes,
obviously,
sir.
what will be happening that for this particular one, T2 minus T1 will be giving multiplied by. Suppose you choose which one you choose. Suppose you are choosing the driven pulley. You do not know that condition, so you have just chosen the driven pulley. So driven pulley will be giving you a torque of how much? It will be giving you T2 minus T1 multiplied by its corresponding radius. All right.
Yes, sir.
So this particular power transmission, when it comes down over here, then obviously this particular pulley has a capacity of T2 minus T1 is much lesser.
Yes, sir.
Are you getting my point? Okay.
Yeah.
So what will happen? The power transmitted when it is coming down, if it is the higher compared to the ratio, then what will happen? The belt over the driving pulley will be continuously going on slipping because it is exceeding the capacity. T2 by T1, it is exceeding the capacity because this is lower value. However, if I choose T2 by T1 equals to 2, so T2 is 2, so that will be giving you a lesser transmission because the ratio of T2 minus T1 is much more less. Are you getting the point?
Yes,
Hello?
sir. Yes,
So
sir.
obviously, if it is transmitting lower power, then that will be obviously lower for this particular pulley, no doubt. But
Yeah.
there won't be any slippage
So
because
no
it has got a
since you're
higher capacity. Isn't you are getting the point?
yes,
Okay.
sir.
So that is the reason. So
So we
obviously,
just to ensure
yes, hello.
yeah, so we are doing this to ensure that there is no slippage at any of the pulleys.
Any other pulleys. Okay, theoretically there are no slippage. Okay, for other practical purposes there could be something, but that is different issue. All right. So theoretically there should not be any slippage. So obviously when there is a belt drive, this is important only for the belt drive. When there is a power transmission occurring through a belt drive. If it is single pulley, then there is no question of that particular condition arising. All right. So
Yeah.
that is the reason. That means the power capacity will be going on changing.
Sir,
Yes,
Okay, thank
sir, can you please help me to show, see how to find direction of friction in right side pulley, driving pulley?
driving pulley. Okay, it is given over here. See, driving pulley, driven pulley is okay. Driving pulley. You asked me for the driving pulley. Okay, now driving pulley is already powered, isn't it? You understand the driving pulley is in the rotating condition. Belt is not touching right now. Just for an assumption, belt is not touching. So it is having an anti-clockwise rotation. So the moment belt is stationary, mind you. When the stationary belt touches this particular pulley, so what will be the friction onto the belt? It will be in the upward direction. Hello.
Yes, sir. Yes,
Yes,
sir. I
sir.
got it.
It is in the upward direction. So,
Yes, sir.
so obviously, because this will be opposing the motion, so it will be onto the pulley, it will be downward. So the belt itself will get a reaction on the, I mean, friction on the upward direction. So now I am stretching this portion of the belt that I have shown over here in this figure. If I stretchen it, then this is T1 and this is your friction, say F. That's I have not written anything. This is a friction F. So what is the equilibrium of the belt? T2 equals to how much?
T1
T1,
plus F.
T1 plus
This
F. So
friction.
obviously what is happening? That T2 will be the higher tension side. Okay. So that means always remember,
Hello, sir.
yes.
The direction of rotation of a smaller pulley should be in opposite direction, sir.
Hello. Hello.
Yes, sir. Hello.
I could not listen to you properly. Once again, can you repeat it?
The direction of rotation of a smaller pulley should be in opposite direction.
Why the friction, which is opposite direction? Friction on the belt is opposite direction. It is your voice is breaking. That doesn't matter. Once again, you try out. If I can listen it once again.
Sir, if we take torque of friction on the pulley, a smaller pulley, then torque is in opposite direction. Then rotation will be in opposite direction.
Oh, acha, acha, acha. If I have understood your problem, if I multiply T2, T1 minus T2 minus T1 multiplied by R, it is in opposite direction, isn't it? That you are telling. Am I correct?
Yes, sir.
Oh,
Yes, sir.
yes, it is opposite to this particular torque that is applied. Okay.
Yes, sir.
Yes,
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 sir.
fine. Okay. Just to explain this fact, can I go to the driven pulley? Just to explain this fact. Okay.
Yes, sir.
Okay. Now you can see that this particular uh, driven pulley, driven pulley is getting driven pulley is I have shown this long arrow. This is the T capital T small t. Okay, just let me increase little bit figure. It is getting okay. Okay, I have just increased little bit. So you can understand that what is happening is that in this particular case, T2 minus T1, it is in the same direction. It is equals to TT. So T equals to T2 minus T1 multiplied by its radius. Okay. Now, in this particular case, what is happening? The
There is a
belt,
lot of noise
Sir,
from
some
the
background noise is coming. Can you mute, sir?
which one?
Hello, sir. Noise.
Some
Can you?
see others, please. If I mute everyone, I won't be able to listen to you again. Okay, raise your hand. Okay, it doesn't matter. A little bit of this thing. So just don't interrupt that this particular one. Let me continue with this. So T2 minus T1 into R is a power transmitted to this particular pulley. Look, the belt was in moving and this belt through friction, through this friction onto the pulley, which is the belt is applying due to its rotation. This power is coming onto this pulley. Now, what this pulley is doing, you can see there is an opposite torque in the dotted line given as TT, something what has written TR. Okay. Now that is called the resistive torque. What is the resistive torque? This driven pulley is attached to an equipment, say pump. It is attached to a pump. So obviously this TT will be trying to overcome the resistance offered to this particular pulley, the particular power, that is a pump. So what is a pump? Pump is doing some work, it is lifting some water and etc. So it is doing some work. There are certain amount of bearing friction, gland friction and other friction. So basically it is driving this particular torque is being spent on the torque is spent on what? Spent on overcoming a resistance. So that is the natural law. That means if you apply a power somewhere, then obviously there will be
so there is
certain
some
amount of
background
resistance,
noise.
that it will be overcoming. So in this particular driving pulley also, this particular power is being given. So the driving pulley will be going on accelerating, but it is not going because of the fact this particular power is getting transmitted to the belt, for which for this pulley this T2 minus T1 into R is the resistance. So this particular power has to also overcome certain amount of resistance. Okay, so that is the reason what is happening. This T2 minus T1 into R is actually the applied resistance. I should not say applied resistance. This is the resistance that this particular amount of this particular torque applied to the driving pulley from some electric motor is coming into picture. So this is, in this particular case, T2 minus T1 into R is the resistive force for this particular driving pulley. And for this one, the equipment attached to that one is the resisting force. The equipment is resisting force where the input force has come from T2 minus T1 into R. That is the power that is being transmitted to this driven pulley. And the resistance is the equipment what is attached to this particular pulley. Now, in this particular case, driving pulley has got a power and it has to act over a resistance. Okay, so that resistance is T2 minus T1 into R. That is the answer. Just look at any electrical circuit. In the
Sir, can
electrical
you say
circuit,
once again what you said last few seconds?
most in the most cases, again your voice got break. This particular one is power. So there is where the power will be this power has to be utilized, or it is actually using in this transmission system. Now in the transmission system will only operate under a loading condition. There will be certain amount of load has to be applied to any system. Just I'm giving you an example of an electrical circuit. So if you give a bulb, then bulb is the resistance in the circuit. For the reason the voltage is required. Okay, this voltage is a source for which a current is going, and that has to overcome a resistance to glow the bulb. Now in this particular case, what is happening? That this is the driving pulley. It is driving. Now for this fellow, T2 minus T1 into R is opposing in the direction. That means this is the resistance. So that means this particular one transferring, acting over a resistance. And by virtue of that one, that resistance is coming due to this frictional force. Okay. So that frictional force is basically is appearing as two different belt tensions. So these two different belt tensions is applying a resistance moment onto the resisting torque onto this driving pulley, and by virtue of that it itself is moving in this particular direction. Okay, because this friction is transmitting this motion to the belt. So the opposite direction to be in one sentence is a resistance to the driving pulley. So this is a load to the driving pulley, and at this particular one the power transmitted through the belt is actually onto the pulley in the same direction, but it has to also have a resistance. That resistance is actually a load attached to that, and the example of a load I am just giving just a pump attached to this particular pulley. That means obviously that has to run a load. Why that is a load? Because there are certain elements. The bearing is there, it is eating away certain amount of load. There are the what you call, there is the ceilings are there, that will be also taking up some load. Then more and more more or less what having, you are pumping the water. So what pumping and water, you are doing some work done. Okay, that is a load. So there should be a load if you are always applying a prime mover. So that means obviously the power will be only working if there is a load. So this is that maintains the equilibrium of this particular system. So in this particular case, T2 minus T1 into R is the loading onto this particular driving pulley. I can tell in that manner. That's the reason it is in the opposite direction. Is it clear to you? Hello? Hello?
Yes, sir.
Yes,
Yes,
sir.
yes, sir.
Okay, so that's the reason. That because the confusion will come here, it is in the same direction, but why it is here the opposite? No, it is not like that. Here, this particular power transmitted through the belt is responsible for moving this driven pulley. But the driven pulley is, if it is not attached to any load, it will just go on accelerating because there is no load in the system. So there is certain load in the system, there is a load in the system, so system is balanced. Okay, so obviously for any electrical circuit, mechanical circuit, so everywhere you have to have a load is balanced by the motive force that is actually operating on it. So it is a motive force and load balancing. That is the what the T2 minus T1 is in the opposite direction. Okay, for the driving pulley. Sorry.
Sir,
Okay.
hello, sir.
Yes.
So practically, the rotation of is in opposite direction, but when we see theoretically, that is when we know the
Where is
direction of
practical?
torque, then
Just 1 second. Which direction you are trying to mention? The belt is
sir, yeah,
moving. The entire system is moving in the anti-clockwise direction. No,
yes,
which
sir.
direction you are talking about? Entire thing is in anti-clockwise direction. This pulley is moving in the anti-clockwise direction. This pulley is also moving in the anti-clockwise direction.
Yes, sir.
Yes, but what you are
But
telling?
when we theoretically know the direction of torque, then it is an opposite direction on driving pulley.
Well, no. Look from that one. Look from this one. Driving pulley was rotating in the anti-clockwise direction. Driving pulley is rotating. There is nothing. This particular pulley is rotating. How it is rotating?
Yes,
This
sir.
is so
It is rotating in anti-clockwise direction. Yes, sir. It
exactly,
is
and the
clear,
power
but
is getting transmitted from this particular one. Yes. Then what is we talk about theoretically? What you just told me theoretically?
T2 minus T1 into RS.
Okay. Okay. You mean to say the belt, that is not the rotation, that is the resisting torque. Okay, that is the resistance to this particular pulley. There has to have some resistance. Are you getting my point? Hello?
So T2
So I think
minus
we're
T1
getting
is the
confused
resistance
because
for
Yes,
some
okay,
point that
just 1 second, just 1 second. Can I talk about in the other way round? Can I talk about in the other way round? See,
yes, sir.
when this particular pulley is rotating, then when the belt touches, then what is happening onto this pulley? You can see the friction force is acting in this particular direction. Clear? Downward. Hello. The friction
Yes,
force
sir. Yes.
onto the pulley is downward. So if
yes,
I
sir.
take the simply the moment of the friction force, then what you get? It is a resisting force. Where from it getting the resistance? From the friction from the belt. Are you getting the point? Hello.
Yes, sir.
Yes, sir.
Then we can apply the
Yes, sir. Yes.
equation
Okay.
of
So
equilibrium
now
for friction and the tension, and
this
then we can
particular
do the
equilibrium equation T2 minus T1 is basically nothing but this particular friction, that is the reason it is T2 T1. So T2 minus
yes,
T1 is the
yes.
distributed friction force over that one. That friction force is actually is coming due to what? So that friction force is responsible for the differential differential tensions in the belt. So without looking into inside, I do not know the friction force distribution, okay, but I know the T2 and T1 gross value of the tensions that is appearing due to the existence of friction which is coming from the belt. So automatically T2 minus T1, in the other way around, we can talk about that frictional resistance that is coming from the belt by virtue coming from the belt, which is basically resistance, because friction is always giving a resistance, this particular one. So therefore, here friction, that is the application of the friction. So here friction is responsible for giving a loading to the driving pulley. At the same time, what is having the friction onto the belt is creating a motion of the belt. Okay, and that motion is being responsible for transmitting the power to another system, that is the driven pulley. Okay, hello.
Yes, sir, got it.
So
Yes, sir.
okay,
Sir,
so there is nothing like theoretically. Okay, there is not theoretically it is rotating. No, it is theoretically or practically what is it is rotating in this direction. T2 minus T1 into R is basically a resisting torque, clear, to this particular system, because as I told you, if there is a load, there will be a resistance. Okay, so then that way a system works. That means anything you are going, then you are there is a resistance. Okay, so when you are just pressing your switch of your computer, what is the resistance? Because your computer is working, because there are a series of electrical circuitry inside, that is the resistance, and that is actually working. Okay, when you give a battery voltage to the entire system. Okay, so that's the reason your charge is going out. Okay, so you have to charge the battery. All right, so there will be a resistance to any system. So that is this is the same thing. So this is also a mechanical resistance is coming due to the friction. But the beauty is that this resistance is actually driving the belts, and that's the reason entirely the friction is responsible for power transmission. That is what is the basic concept of the belt drive. Okay.
Sir, T2 minus T1 is equal to downward friction, na?
T2 minus T1 into is what friction you told?
Equal to, sir, equal to
Equal to what?
downward friction.
T2, see this particular downward friction means I could not understand. What do you mean by downward friction?
on the belt it
Downward
is
force.
upward, and on the driving pulley it is downward.
See, I am just trying to I am trying to understand your because I'm not able to see you, but I'm trying to understand your idea. There is, don't think in that particular manner, downward or upward or something, not like that. You just try to find out what should be, just you considering the relative motion between any two bodies. Then you, in this any two bodies, in this particular case, one is a pulley, another is a belt. Okay, so now you try to find out in which direction the friction on the belt is appearing. So friction on the belt is coming out to be, from the physical scenario, we can see the friction on the belt is appearing in the direction what I have drawn over here. Okay, so if I want from this particular one, it is only obviously evident that if I have not named, I have just named this is T2 and this is T1. I have just named. So now from the logic of this equilibrium, then I can understand that T2 is an higher side and T1 should be a lower side, lower tension side. That is the concept you're telling. Okay, so downward and upward all depends upon the how the relative motion between the belt and this particular place is taking place. Okay, so so that is the thing. In this particular case, you see the belt was moving, pulley is stationary. Just look into the fact, belt is moving, pulley is stationary. So what will happen in this relative scenario? What will be happen? This pulley will try to prevent the rotation of the belt. So therefore, the friction force acts on the upward direction, and in that process, pulley gets the downward friction, and that creates the motion of the pulley in the anti-clockwise direction. Okay, that is the thing. But if you talk about the high tension and low tension, just simply remember this: end opposite to direction of friction on belt is in high tension. So end opposite to direction of friction. This is the belt end. Well, I should have written belt end. So end, that's anyway, I have arrowed, this is the end. Okay, so this is the end which is opposite to the direction of friction. So this end is opposite to the direction of friction. So this is an high tension. That's all. Okay.
Hello, sir. Last one dot, sir. Sir,
Huh?
the
Now, how
friction
do you
on
know
a
this is the
small
last
pulley-
dot? Last, others might have any question. Okay, tell
Sir,
me.
for me, sir, for me.
Okay, fine.
So the friction on a smaller pulley is the cause of rotation of a smaller pulley. That is driving pulley.
Friction onto the yes. No, it's absolutely wrong. This pulley, the driving pulley is powered, it is rotating. Driving pulley is not at all stationary, it was rotating by a motor. A motor is attached to this driving pulley, it is moving. Now belt is stationary. I'm just coming and touching the belt. The moment I touch the belt, then automatically the belt will give a resistance to the motion to this resistance to the motion of this particular pulley, and the belt itself gets a friction onto the opposite direction. No, this is belt is no way responsible for the movement of the driving pulley. Driving pulley itself is a motor. I think I've written somewhere. Let us consider driving. In this case, the pulley rotates in the direction of applied torque. The belt will oppose the motion of the pulley. So in this particular case, I think in my lecture I have just told who is driving pulley. Driving pulley is the pulley which is driving. It is a motor is attached to that one. Okay, so this particular the driving pulley is already powered pulley. Okay, so that is important. I think did I not talk about this thing in the earlier slide? Just one second. Okay, the basic principle is written. The prime movers like electric motors, IC engine, etc. used to rotate the driving pulley through application of moment TA. Okay, this is the same diagram. So this is actually IC engine or any motor, it is driving it. And this power which is transmitted by the motor is being transformed from this thing to this particular pulley, which was earlier it was in a without any motion, and it gets the motion from this particular particular belts who gets the motion by virtue of the friction contact from this particular pulley. Okay, so that is the thing. Driving pulley is already a powered pulley. Okay.
Sir?
Basically, okay, sir.
What is happening is the okay.
Hello.
Yes, sir. Actually, I was trying to say that basically what is happening is that the driving pulley is being given the torque by the motors. It is then applying the friction on the belt, which was stationary, and this rotates the belt, and this again applies friction on the driven pulley, which rotates the driven pulley. So is this how it is, how the power
Exactly.
is transmitted?
Exactly. That is the power transmission. Okay. Okay.
Okay, sir.
So this particular power transmission, who is the mediator? Mediator is friction.
Yes, sir.
Friction is not running with them. Friction is just mediated the initiation of the power, okay, for which the belt starts rotating, okay. Because what is happening, so that's the reason in the T2 minus T1 we are considering an impending slippage. Before that, if it is slipping, then everything is gone, no power transmission. So just before slipping, what is happening, the friction, contact friction is not, the contact friction is little lower than the slippage friction. So the belt is automatically, by virtue of friction, it is rotating. The belt is getting drawn by this particular one. As a matter of fact, this particular belt will be drawn over here. So the belt at the very beginning, well, I do not want to go to the complications, because this particular one will be dragged just like an any member. It will be pulled by this particular friction, and moment it leaves the sieve means I mean to say the pulley, then that will be relaxed. Okay, so the belt, this rubber belts will be having, internally it is not always fixed. It will be having certain amount of stretching during the portion the friction is acting onto, and then the stretching will be relieved where there is no contact. Again a stretching, then again it is relieved. Okay, so that way also, that is also a physical happening. This normally happens, but at this instant you do not have to bother for those things, because that will be coming for that particular scenario, where the people who designs the belt also take care of that one for the high life of the belt. Okay, how to take care of this
Sir,
continuous. Okay, fine.
so after determining the direction of friction, you have written T2 is greater than T1.
Yes.
Okay, sir.
No. I told yes, sir. No, not like that. I have denoted T2 and T1. I did not know earlier. Okay. Okay, I could have written something here as P, something here as Q. I do not know which is higher side. Now I look at the friction direction. So I understand that friction plus P must be equals to Q. Okay, so Q is higher tension. Are you getting my point?
Okay, sir. Yes, sir.
Okay, other way around. I have written just T1 and T2. Had I written the T2 higher side, T1 then T1 in the lower, then I would have told T1 is greater than T2. As a matter of fact, in some books you will be finding out. Have you found that all books will write T2 is the higher tension? No. Some book will be writing T1 is higher tension, T2 is lower tension. Then you will be saying no. So
Sir,
notation is not important. It is important which side is a higher one. Okay.
excuse me, sir.
Yes, sir.
So I had doubt in this formula of the length of open belt, sir. Actually, the last term of that formula I didn't get, sir.
Last time.
Yes, the 1 by 4c in bracket dl minus ds square,
Okay.
sir. So I did not understand that term, sir.
You do not have to
Yes,
understand
sir.
at this moment. I have written this note. This is particularly this L2C is that this particular one pi by 2. Pi by 2 means this radiant of the DLDC. But only thing, there is certain amount of approximations involved, because this is a circular arc is being. See this beta. Beta is not exactly a straight line. It is little bit of curvature is there. So certain amount of approximation is there. So I have just given you the formula. I have not giving you the derivation. I have never told you to derive. Otherwise,
sir.
I would have derived it. Okay.
Okay, sir.
Just it
So
is just for a language.
So in the
Sir,
nut and screw system,
Okay. Knot
sir,
and screw system. Okay, I'm going down. Okay, anyone of the belt still left? I am just leaving this particular slide. I think I will leave this.
Yes, sir.
I have talked enough on
Yeah.
I suppose. Okay.
Sir,
So I'm
one
just
question though.
this. Okay.
The driven pulley is always having a higher diameter, and this is just to multiply the torque, like uh, because
Which one
with the higher.
driven pulley is higher size. You are talking about that?
Yes, sir, that is to yes, sir, that is to multiply the torque.
Well, it is a normally it is just given the driven pulley of the higher side. No, actually it is not like that. Okay, both the pulley could be same size. Okay,
Okay,
just
sir.
okay. Just what happens? We are getting just 1 minute. Others, please listen to this one. See, if I buy a, just forget about IC engine. If I buy, you are in first year. When you go to the second year, you will be learning about electrical machines, or you have already started electrical machines. I do not know exactly. Okay. If I buy a motor, okay, as all the motors normally you see, okay, in our household pumps and other things, the motors are normally having two kinds of speeds. One is 900 rpm, three kinds probably. Okay, so if I'm not wrong, the most common motor speed is 1440 rpm. Hello, if you
Yes,
buy
sir.
a,
Yes, sir.
it is 1440 rpm. But
Okay, sir.
in now I want a speed very smaller. 1440 rpm is very high speed. All right. So if I require a device to be running at a lower speed, I will make the that particular size larger, small. I will make it larger, isn't it? Hello.
Yes, sir. Yes, sir.
Anyone, that's the way the pulley sizes are determined. Okay, my requirement
Oh,
is
okay, sir.
running, driving and equipment. Now I have to adjust the pulley diameter such that it gives that particular speed of rotation. Knowing that 99% case 1440 rpm are the motors available. Okay, so accordingly I have to choose the driving pulley and driven pulley size to adjust the rotational speed of the actually the load I am intend to run through this belt drive. Is it clear? Fine. Okay.
Yes, sir. Yes, sir. Got it. Thank you.
So now come down to something on the screw. People you are being asking. This problem is very simple. Okay. This problem also you have understood. Uh, Now I have come down to the screw. Okay. Now on this page you have anything to talk about?
Yes, sir. I did not understand the lead angle alpha. So how it is L upon 2 pi rem, sir? Can you explain?
L divided by 2 pi rm. Okay. Huh.
Yes, sir.
Just 1 second. Just 1 second. Give me 30 seconds. 1 minute time. I just on.
So you can take entire time. It's all yours.
Hello. Acha, by the way, now I have come back. As a matter of fact, one person inside here has got some urgent signatures to do. Okay, so I muted you. Okay, so now you could not understand tan inverse L by 2 pi rm. Acha, by the way, if I replace this L by P, do you understand? Hello?
No, sir.
Uh,
Problem is 2 pi
so
r.
yes, sir.
I
It should be
replace
only
this
2
L by P. P means pitch. Okay. Instead of writing L, I write pitch P. Okay. This is the pitch P. Okay. So that P divided by 2 pi Rm is alpha equals to tan inverse P divided by 2 pi Rm. Is it understandable to you?
No, sir. How, sir?
Sir, what
Problem.
is the number
No,
of starts?
It
okay.
should be sir 2 rem, sir, according to me.
Yes, sir. It will be one. So five
Can you
is.
please explain
No,
how
no,
do
just
we
one
get
second.
from the
Just
L
one
equals
second.
L, please?
Okay, just 1 second. So this is very surprising because in a physics class, have you not learned about this pitch, screw pitch? That what is that particular instrument called? I just getting the out of my mind. Okay, so in the physics laboratory,
Vernier caliper.
Screw gauge.
it is
Screw gauge.
Yes, sir. Speech.
not the screw gauge. You have okay. It's a screw that smallest one rotation will give me that much of movement. So the pitch of the screw, something like that. It is
Least
there.
count.
So that is the same thing.
Screw gauge.
Yes, sir, we know pitch.
You know pitch. What is pitch? What is
So it
pitch?
is the distance moved by the screw in one full
One
rotation.
full rotation.
One
I take a screw in my hands, a small screw. The nut I keep on. I mark with a pencil. I just simply rotate one. So how much is the distance traveled is the P, isn't it? That is the pitch of a screw. Is it clear to all of you? Okay. Hello. Now
Yes, sir.
what's happening? Just look at this particular. Look at this particular figure. So that is equivalent that if I measure some same point, two consecutive threads, that is pitch. The distance between two consecutive threads is basically it will be pitch, because that is the one it will be rotating by one thing. Now what is happening in this particular case? I am getting a linear distance. Pitch is a linear distance, but what is happening by one turn? What we are doing? We are getting. Suppose I cut the thread, and that one turn thread I stretch it. Okay, one turn thread I stretch it. So I go to the next slide. Just listen to me. Okay, so one turn thread I stretched it over here. You got the point? This particular blue color is the thread. So this thread, if I had coiled it, then it comes out to be what I just told you. It comes out to be there's some helix that it is winding over. Now I am straightening that screw. I mean screw thread, not screws. Sorry, screw thread. So that thread portion I am straightening. So this is the starting point. Can you see my cursor? This is the starting point, and then it is riding, and from this starting point it is the ending point. So this is, I talk about pitch. Forget about L. I am not talking about L. So this is the pitch. So just to travel this particular one in the linear distance, we have just moved by a circumference from one point to one in the perpendicular plane to the axis. We have moved by one circumference. What is the circumference? 2 pi rpm, 2 pi multiplied by rm. So 2 pi rm is the circumference, and it is going up by one pitch. So I just draw one triangle. So tan alpha equals to P divided by 2 pi rm. Is it clear to you? Hello?
Yes, sir.
Yes, sir.
Now the question this is because instead of drawing a picture, so I have just this already done. Now coming down to our your question, L divided by. This is relevant. I understand L is relevant because you have not heard of that one. So just to start with L, probably I have talked about in my video. L is called lead. Now just take any jam bottle. I have told about jam bottle probably. Just in the, yes, hello. Let me complete. Okay, so I have taken a jam bottle. So if you just look at this particular lead of the jam bottle onto the glass bottle, you will be finding out the threads are there, but it is not a continuous thread. You will be seeing that pieces of threads are placed onto the periphery. Now these pieces of the threads are not continuous. It is cut, and not only that, it is not a single one. It will be, if you will be finding out one thread, little above there is another thread, probably no more than 2 threads are there. So lead is that where n is the number of starts. That means what is one? Suppose onto this body, onto this screw, I have drawn a single screw. Onto this screw, parallelly some other profiles of the similar nature also I am just winding. I have taken one thread. I want that I just winding the thread just like a screw. Then I take another thread just after that one. Say this is a white thread. Next one I took a blue thread to wind. Next time I take an red thread to wind. So all these are similar type of threads, but there are number of threads like that. So what is the advantage of giving a number of, instead of one thread, number of threads onto the same body? This helps in quick engagement and quick disengagement of the screws. Okay. So what I mean by quick engagement and disengagement means just by one rotation you are moving much more. That means that means what is happening? The attaching with other mating portion becomes very quick. In the jam bottle, you just give one little turn, it will be going to the entire end. Then you just give a little turn on the unwinding direction, it will just come out. Okay, so this is also in the that you have never seen. The petrol tanker unloads in the petrol pump in the similar manner. They have very hose pipes, and the end they couple with another tanker. I mean another system which is in the petrol pump. Okay, so they will be just simply coupling with a tanker, just this type of quick engagement screws. Means they will just give one turn, it will be going for a larger distance and it will pick up. Okay, so for quick engagement and disengagement, this type of screws are taken. So now that therefore lead L, that is called lead. So L is equals to N multiplied by P. N, as I told you, number of threads wound over a single shaft, and multiplied by pitch of each thread. All are similar type of threads. So that is NP. So if there is only one N, then L is equals to P. There is no difference between L and P. That is the situation. Okay, so that is the reason the lead angle becomes.
Can you explain the yen?
Huh?
Yen. So I did not get yen, sir.
Get which one?
So one is yen, sir. So L is equal to NP, where N is the number of stars. What is the meaning of the stars?
As I told you, suppose you are taking a pencil. Onto the pencil, you are winding on white thread, just like a screw. Okay, that you can do. Just beside that white thread, in the same manner, just beside that earlier white thread, you are just winding and red thread. Okay, so there is another thread. Then just beside the red thread, in the similar manner, touching the earlier one, you wind a green thread. Then how many number of threads you have made? You have made three threads of the similar type. Okay, yes, sir. That is N. Clear?
So actually, L represents the length of that screw, sir. Can we tell that?
L do not represent the length of the screw. Sorry, L is called the lead. Lead means this product of N and P. Lead means by one turn, in this particular case, how many threads you are having? 3 threads you are having. Suppose pitch was 1 mm. That you are winding in such a manner that pitch is 1 mm. What is pitch? First turn to second turn, the distance is 1 mm. Second turn to third turn, distance is 1 mm. So that is one screw you have made by white thread. Just beside that one, as I told you, one red thread, another is green thread that you have made the threads. Now in this particular case, then what will be happening? In earlier case, by one rotation, you are moving 1 mm. Now by one rotation, you are moving by 3 mm. Are you getting my point? Hello?
Yes, sir.
You got the point? Okay. So number of the threads are absolutely identical, but more number of threads in parallel to each other. So obviously what is happening, by one rotation, you are moving the linear motion, what I have given you over here in this figure. The distance of the linear motion for a single thread is 1 mm. For 3 threads, it will be 3 mm. For 5 threads, it will be 5 mm, like that. So what is happening? Just by one rotation, you are engaging to a larger grip. Okay, so that is the what it is called and quick engaging and quick disengaging. Means you have to cover certain distance. Okay, so by the screw. So if you are having a number of thread starts more, then you can move by one rotation more amount of distances. That is called the lead of the screw. Okay, so that is the L what I'm talking about. Okay, hello. Okay, got the point?
Yes.
Yes.
So anything else on the screw?
Sir, why alpha equals to tan inverse L upon 2 pi Rm? Why it's not tan inverse L upon Rm?
I won't repeat it. I'm just repeating it. So L upon Rm, it's not why. I just explained the feature. Right now I explained the feature. You didn't listen to it? I just right now explained what I told you. I show you the next figure? Just right now, you ask your friends. I just explained it. Right now, that's not even 3 minutes. Okay, I just explained it. One winding of one thread. Just forget about L. Forget about one single pitch. If you are, it is the last time. This is the last one I'm just talking about because I have told this blue one is the thread. You have wind a thread by one rotation. Okay, so by one rotation, how much you have moved out? 1 mm, pitch is 1 mm. So now that thread you cut off from the thing and you stretch it as a straight line. So that straight line is the blue color straight line. So this is the thread which was winded onto the body. I have stretched it. And if I have stretched it, this is the beginning portion and one end is the starting point and other is in the ending point. What is the ending point? Ending point, why it is raised? Because by that time it has gone up by an value P. Okay, so that is the pitch. So and what is the distance travel in the y direction or in the vertical direction? You move by P, and in the horizontal direction, how much you have moved? You have moved by the circumference of that particular movement. What is one revolution? One rotation. One rotation is only one circumference. So circumference is 2 pi Rm. So tan alpha equals to P by 2 R1. Why P I am saying? Because if I consider a single start, n equals to 1, L equals to P. So I have written here only L. Okay, so L equals to P when n equals to 1. Now you have got the point? There is no question of n. But it is very surprising that why you are passing out JE and you do not know the pitch of a screw. It is very common in the physics course. That is anyway, I have tried to explain. I hope you understand by now. Okay. Hello.
Yes, sir.
Okay.
Yes, sir.
Okay. Do you have any quick questions in 1 or 2 minutes? Because it again
So,
4 o'clock
so
another
actually
session.
the winding and unwinding condition I did not got, sir. So actually the last one, that theta, so alpha and
Okay, very quickly. Acha, by the way, you received this particular figure in my original script. There was
yes,
a mistake of the F direction. Okay, so I just while talking to other batch, I just found out that by mistake it was my mistake that by mistake it was in F. So why talking about? I talked about the F only. So this is now the corrected figure and we have mailed to all of you this particular correction of this one. Okay. Now very quickly I'm just talking about. Okay. Now when alpha is greater than phi. Okay. So just look at pictorially. So alpha and phi both are measured from normal direction. Is it clear? Okay. So alpha, this gives you alpha. Alpha is a normal and vertical. Angle alpha is normal between normal and the vertical. So this is the alpha that you have understood. And phi is the angle between normal and the R. R is the friction, the resultant of the friction and normal.
The resultant force.
Pardon? Hello?
So, no, I said what is R, the resultant force.
A resultant force. Okay, so this resultant are the red color resultant. This is important. So now in this particular condition, if I draw the R, extend the R, then I can have two components. One in the direction, but I mean I'm just only interested for the direction in the towards the left, in a horizontal towards the left. So the horizontal towards the left is nothing but R into sine alpha plus phi. That all of you understand. Why alpha plus phi? So obviously this angle is alpha minus phi. So alpha minus phi, this is this particular one. So obviously yes.
Sir, I do not understand how you write AMR because the direction of RM and R sine theta minus phi would be same, na?
Or
Yes, sir.
Sir,
I also don't understand how we are writing
yes,
the
sir,
moment
every
equation.
I don't understand. RM and the direction of R sine phi
The
minus
moment
alpha you
equations
have
about
written.
which
Direction is same. So
Yes, sir.
how you are taking cross product? It will be zero, na?
cross
Sir,
product.
how RM is there in momentum, sir?
Yes, sir.
Yes, sir.
AMR the we are taking moment, na? RM
Just
in.
1 second. Will you tell or you will allow me to talk?
Yes, sir.
Okay. Have you understood the direction of R first?
Yes, sir. I have understood the direction of
Okay.
R.
So you project it upward R.
Yes, sir.
Fine.
Yes,
What
sir.
is the angle between the vertical and the R? Alpha
So in
minus
the
phi.
upper figure, it will be phi minus alpha.
Alpha minus phi.
So alpha minus phi.
Okay, alpha minus phi. So what is the
The
sine component of alpha minus phi?
component
In
will
the
be
left side,
horizontal.
in the horizontal direction, it is R sine alpha minus phi.
Yes, sir.
Yes, sir. Then what is the moment about this axis, vertical axis?
Sir, the RM direction would be same, na?
RM?
RM also
RM,
in.
come on. You have not understood the figure. This thread is away from the axis. It is onto the surface. Can you not understand? This is the thread going. Can you see my cursor?
Yes, sir.
This is the thread going, and this is the axis of the center point of this one,
Sir,
and this
means we are viewing from top.
this is viewing from the top. So this is the side
Oh,
view.
sir, sorry, sir. I have thought that we are
No,
viewing
you are
from.
thinking wrongly. I've got very less
Yes,
time.
sir. I have thinking wrongly actually. I am seeing from the Z axis, mean perpendicular to XY plane.
Just 1 second. That means you have not read properly. That because the figure screw, I have just given it very clearly how it is coming up. That's the reason I have drawn this particular figure, isn't it? And I have told how the P location comes into, and the very first slide. So now you understand that AMR
Yes,
is
sir. Yes,
what?
sir. I have understood now, yes, sir.
Okay. So AMR represents is automatically it will be coming down. Now it you have understood. Anyone
Yes,
else
sir.
having this?
Actually, I have
I
seen.
did not understand the direction of friction in figure 4D. Sir, can you please explain the how you took the direction of friction in figure 4D?
Just 1 second. I have not drawn the direction of friction force figure D. I have tried to draw the resultant of the friction. And can you understand
No,
it?
sir.
If it is N and it is F. Just try to understand. If alpha and phi I am just talking about. What is alpha? Alpha is the angle of the plane.
Lead angle. Yes.
So that is plane angle. So plane angle is measured from which one? The normal and the vertical. Clear?
Yes.
Yes. Fine.
Yes, sir.
What is phi? Friction angle. Fine.
Yes.
What is the distance? How you measure the friction angle from the normal direction to the R? Is it clear? R is the result.
Yes, sir. Yes.
R is the result. Fine. So R is the resultant. Now N I know, there's no dispute about N. N has to be perpendicular to this one with an arrow upward. There is no dispute.
Yes, sir.
So if this has
Yes,
to be
sir.
R, then automatically N, F, the resultant R will be the way I have drawn. Come on, this R has to be shifted over here. That's all, nothing else. But the R direction is okay, perfectly all right.
Yes, sir. Yes, sir.
Yes,
Got
sir.
the-
Okay.
So automatically F will go on the other
But sir,
direction.
external movement direction is reversed, sir. You see figure 4C and 4D, external movements are opposite in direction. So how can friction be in same direction?
Come on, it depends upon the R. Just 1 second. I have talked about you. Just 1 second. I can take another session, but before that, you read it properly. You have not read it. The unfortunate part is here you are trying to understand and asking me the question. You have not read it. Okay, you read it. Say your Atul Jain. I will talk to Atul. I can arrange another one before you read it. You read this particular text very carefully. Don't listen to this particular my voices. Okay. Look at the R. If the R is going, I am just talking about what is the resisting moment. Just now I talked about belt drive. The resisting moment is in this direction. So there will be another moment which were unwinding. This is the resisting moment will be in this direction. So therefore, to prevent it, aim has to be opposite. So each has got different connotations. Our directions are not the same. How it can be not? You just read it, you think of it carefully, and then ask me. Okay. All right. Hello. Have you seen this particular picture 4C? Is the R same as
Yes,
4C?
sir, I understood.
Okay.
We have to stop the screw from unwinding automatically in 4D. So we have to apply a moment. I understood. Yes.
And that is not desirable. That is not desirable. You know what will happen in this case? You hold a screw and then you tight it. The moment you leave your hand, it will be just falling down, unwinding. Is it clear? Okay. Now here it is supported by the direction of friction. Direction of friction upward means the screw is going downward. Screw thread is going downward. Okay. Fine. Just like that. Screw is going downward. But here the difference between these two, it has got the resisting moment in this direction and it has got the resisting moment in the opposite direction. So as because the resisting moment in this direction is in this direction, you require a moment to unwind. Here the resistance direction is in this direction, so you require an opposite moment, external moment to keep it not getting unwind. That is the difference. Okay, fine. So I leave it right now because another batch is waiting for this particular one. Okay.
Sir, actually, I don't understand the figure properly because in which angle, mean from which plane we are seeing. Because the reaction we are applying, it will be from downward direction, na?
You just once again you read it. If you are having, you give your name and this thing. You read it first. Just right now you told, okay, sir, I made a mistake. I could not understand. Okay.
No, sir, I have read it before, sir. Because the figure I am confused because
no, which is the confusion? One figure you got confused. I cleared it. So that is the all figures are drawn in the similar manner. There is no change. The screw you are seeing is some distance away from RM. Okay, the screw you are seeing is at some distance away from RM. Just look at this screw. This is the screw profile. Just can you look at this particular top view? Hello.
Yes, sir. That
so
top view.
this is the screw profile. So what I am drawing is on the screw profile, mean radius of the screw profile, but the axis is always RM away. So if I look from this side, can you understand that axis is going from the center point? It is very difficult. So I've given in the very first slide that where the axis location and where there is a screw profile directions. So obviously in this particular figures, any figure you pick up, this blue color, this particular screws are actually what is happening. It is away from this axis. Okay. All right. Fine. Okay.
No, sir, I do not understand.
Then you ask your class teacher. I will tell him to explain it little more. Okay. Or he can fix up. He can fix up another time. You try to look into why you're not understanding it. This is the thread. It is away. This is the P. You can see the arrow of the P. Okay.
Yes, sir. Yes, sir.
So this is the mean radius. It is from the top view, mean radius. So that all the threads are here. All the threads are drawn here. So if it is a top view, if you look from the front view, then this axis and this figure will be in the same plane, isn't it? But
Yes,
basically, it's little away from that one. Okay, so that is the thing, it is happening. So all these happening are on the mean radius. These threads are on the mean radius. So here I have drawn the stretched figure of a stretched thread going through the mean radius. Okay, so that straight thread is going through the mean radius. That is the situation. Okay.
Professor Maiti, this is Atul. I think the other section is waiting, so we have to wind up this class.
So I just telling if they are not able to still they are not able to understand, I will talk to you later on. We can have something session later on also. Okay.
We'll discuss it tomorrow. Don't worry, class. I will try to help you tomorrow morning. Tomorrow afternoon.
No, tomorrow morning also I can just talk.
No, they will have class, I think.
Okay, so thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Sir. Thank you, sir.
Thank you, sir.